did something, I added something to it that I didn't know before. And that's how you can start kind of building in some core knowledge in a wider area.
All right, wonderful. Thank you, Ali. We have another question from Ava, who is an electrical engineer. She's a master's student. And then the question that she asks is that whether an electrical engineer can work in your area, Ali. Then
yeah, good question. So I would say again, the way I think about all of this is get the best people, independent of their background, independent of where they're from or anything. Because the best people can pick up things and can apply their background to different areas. So in our institute, we have number of electrical engineers who are working on different tools and technologies. So as I mentioned, one of the areas that we're very much interested in is to create wearable devices or implantable devices that can sense and deliver compounds. So that's one area. There's a lot of data science that we're interested in incorporating into these different approaches. So I think there's definitely a lot of opportunity, not just for electrical engineering, but I think even beyond and beyond, even philosophy or things like that, people, we have a big initiative at the Institute that we're starting to develop on art and science. So all of these fields, I think, can benefit from each other, and just being open to it and seeing opportunities, I think is the way to do it.
Awesome. Great news for many researchers from different fields. So let's go to those who raised their hand. Mehnush, I think your microphone should work now.
Yes, it works. Can you hear my voice?
Yes.
Hello, guys. Thanks, Dr. Khadem Al-Husseini, for your interesting talk. I am PhD of mechanical engineering, and from mechanical engineering aspects, when I listened to your talk, several mechanical properties is so important for consideration, but I saw that just stress, yield stress, and strain has been considered with you. But as you know, these nanocomposites is under loading, dynamic loading, and fatigue life is so important, or another mechanical properties such as swelling, such as shear stress, friction coefficient, and wear is so important. Have you measured them in your research?
So yeah, it's definitely a great question. So we have looked at some of these because the ones that we think are interesting for some of the properties of the material. So for example, as you mentioned, some of the things like creep, for example, is important. What some of the things related to adhesiveness of the material to the tissues is important. And so I think there's definitely a whole set of tools that technologies that people feel for this class of materials, the embolic, that are kind of material gel-based embolics that are kind of characterized and people use, and even for regulatory, it's important. So we've been kind of mostly sticking with those standard approaches that have been kind of previously published.
And have you modeled this inside the body? And have you measured these mechanical properties? Because modeling is so important, and interaction between these and tissue.
So definitely, I totally agree. And that's maybe an area of collaboration. So I think there's definitely very important kind of modeling type work that is needed as well. So we've done some modeling, but mostly fluid dynamic modeling of looking at inside the blood vessels and shear stresses that these kind of materials get exposed to, but not necessarily the mechanical properties of the material model.
My expertise is atomic force microscope, and I have worked for several polymers and nanopolymers, but not exactly as biomedical tissue. And if you are interested, I'm so interested in collaboration. I will contact you for research.
Sounds great.
Thank you. Thank you.
Thank you. We have Elham Salimi. Can you please introduce yourself, your institution as well?
Yes, my name is Elham Salimi. I'm an assistant professor at the University of Manitoba, just recently started. And thank you, it was a very interesting talk. I really enjoyed it. I actually want to ask, actually seek an advice from you on how to deal with the interdisciplinarity nature of this kind of work and the communication between the people of different backgrounds. Like, I personally find it a little difficult. I have a PhD in engineering, in electrical engineering, and I find it sometimes hard when talking with doctors and medical people, like as if the impression I get from them is that you engineers are intruding into our field. Go back to your own things. So what kind of advice do you have for like mitigating this kind of interactions?
Yeah, well, I guess the first thing I would say is that you can't make everyone happy. So there are people that you should just kind of try to avoid, and situations that you should try to avoid. So that's the first thing. I just think if there's someone who's not ready for being a positive, interactive collaborator, you can't force them into it. The other thing is, I think if you try to learn some of the basics of some of these different areas, and at least through different ways, you can do a little bit of your homework. So when they talk about particular terminology, at least some things about it, right? Some of that comes with experience as you kind of start doing things in a particular area. Let's say if you're doing more biomedical stuff, then over time you start picking up more of the terminology, more of the way different people kind of work. And obviously you need to have a lot of mutual respect. So if that mutual respect is not there, then I would say you shouldn't be trying to force that interaction with those people. And really, down the road, you don't really need too many collaborators. You just need some good ones. And that is all you need. So that's why, for me, when I look at my own past 15 years and my collaborations, there's been just a handful of people that I collaborate, not hundreds of people, right? So again, maybe I've published with hundreds of people, but the collaborators that I've really been interacting with just are a handful. So I think, that's what I would encourage you to do, to find the right collaborators who are interested in, pushing things at the interface between two different fields, and try to kind of go from there. But what you're mentioning, I think, is definitely important, and something that it's more accepted to collaborate between fields and places like, let's say a